Hello and welcome to Cyber Hashira. This video is about slots and token, which I may have already talked about in my previous video. But this video is going to be detailed. I will introduce two new PKCS 11 functions along with some sample codes to demonstrate their usage. Let's get into it. I'll start with a quick recap on what we have learned so far about slots and tokens. A slot is a logical reader which is used to read a token, and a token is a device that goes into that slot. An application would always use a slot number to pass PKCS 11 function calls to a token. PKCS 11 function calls received by a slot is processed by a token, and that's why most applications would always look for a slot with a token present in it. Some examples of slots are USB ports of a computer, card readers, or PCMCIA slots. And some examples of tokens are smart cards, USB tokens, and PCMCIA tokens. I have already talked about cGetSlotList in one of my previous video. It is used to obtain the list of all detected slots. You can also pass a Boolean value to tell whether cGetSlotList should look for all slots or just slots with a token present. Today we are going to look at two new functions. The two functions that I'm going to talk about today are cGetSlotInfo and cGetTokenInfo. They are used to obtain information about a slot or a token. The link you see on your screen is a document which I'll be using for reference. Link to this document is also in the description below. I will start with cGetSlotInfo. Information about this function is available on page 108. cGetSlotInfo is used to obtain information about a slot. This function takes two arguments. The first argument is of type ckSlotID. It is the ID of a slot which an application is trying to get information on. Before calling cGetSlotInfo function, it is generally a good practice to call cGetSlotList first, just to make sure that an application is using a slot number that actually exists. The second argument is of type ckSlotInfo. It is a pointer variable. ckSlotInfo is a structure used to store information about a slot. So when cGetSlotInfo is used on a slot, all information obtained from that slot is stored into ckSlotInfo. And here's what ckSlotInfo structure looks like. Information it can hold are slot description, manufacturer's ID, flags, hardware version, and a firmware version. Here's what a C code calling cGetSlotInfo would look like. There's a slot ID variable that holds the slot number and pinfo variable of type ckSlotInfo. Both variables are passed as an argument into cGetSlotInfo. Information gathered by cGetSlotInfo gets stored into pinfo. These are some return codes that cGetSlotInfo is expected to return. CKR OK means cGetSlotInfo completed successfully without any problem. CKR crypto key not initialized would mean that cGetSlotInfo was called before cInitialize, or cInitialize was not called at all, or cFinalize was called at some point, or any other reason that may cause crypto key to be not initialized. CKR slot ID invalid means that the slot ID which was passed as an argument does not exist. CKR device error means that the slot an application is trying to read has an issue. For example, there could be an issue with the slot like a driver issue, or the slot has frozen, or it could be a hardware malfunction. The next function is cGetTokenInfo. Information about this function is on page 109. This function is used to obtain information about a token. cGetTokenInfo takes two arguments. The first argument is a slot ID. This has to be a slot with a token present in it. To make sure your application is trying to query a slot with a token present in it, it should call cGetSlotList with the Boolean value for token present set as true. The second argument is of type ckTokenInfo. This is a structure used for storing information about a token. Let's have a look at it. And here's what ckTokenInfo structure looks like. As you can see, it stores a lot of information. Let me explain what they are. Label has a label of a token which was set when it was initialized. Manufacturer ID, model, and serial number are some hardware-related information about that token. Flags shows the capabilities or properties of a token. For example, CKF RNG flag would mean that the token has its own random number generator. Similarly, CKF token initialize means that the token is initialized. CKF protected authentication path means that the token has a secondary way to authenticate instead of using a PIN or a password or a passphrase all the time. There are more flags, but I've just listed 3 of them. Max session count is the maximum number of sessions that a token can open. This usually depends on the memory available on a token. Now, there are some vendors who may only allow a fixed number of sessions to be active at a time. Session count is the total number of sessions that are currently open. Max RW session count shows the maximum number of read-write sessions that are allowed to be open. RW session count is the number of read-write session currently active on a token. Every token has a maximum and a minimum length of allowed pin. Total public memory is the total amount of memory available to store public objects. And free public memory is the total amount of that unused memory. Similarly, CK token info has the information about total private memory and the amount of memory which is unused. CK token info also returns hardware and firmware version of a token. Please note this is for a token, not for a slot. A slot may have a different hardware and software version. And then finally we have UTC time. UTC time is a time of a token in UTC. Here's what a C code calling C get token info would look like. C get token info takes 2 arguments, slot ID and CK token info. Once completed, P info, which is of type CK token info, would have all information about the token. These are some return codes that C get token info may return. CKR OK means everything is good. CKR token not present means that the slot ID passed as an argument into C get token info does not have any token present in it. It is an empty slot. CKR slot ID invalid means that the slot ID that was passed as an argument into C get token info does not exist. CKR crypto key not initialized means crypto key is not in an initialized state. And CKR device error means a token did not respond to a command or request which was sent to a token. I will now explain why and when an application may try to execute C get slot info and C get token info. An application may need to call C get slot info or C get token info when they want to obtain some information such as firmware version. Imagine a scenario when there are multiple slots or tokens available on a system. Now, in that case, an application may try to call these functions to make sure that it is using the correct slot and a token. These functions can also be used to get some information about a token, such as its memory usage. For example, an application may try to call C get token info to see if it has enough memory to store new objects in it. I will now take you to my Windows machine where I have prepared few sample codes to demonstrate the usage of C get token info and C get slot info. Let's go. I'm on my Windows virtual machine. Let me show you the samples that I will be executing today. So these are the samples. Now, before I get into C get slot info and C get token info, I want to quickly go over allplatforms.cpp. In my previous video, I used a sample called connect-disconnect.cpp. I had a separate sample code for Windows and Linux. Allplatform.cpp is supposed to work on both Windows and Linux without needing any code changes. So instead of writing 2 separate codes for Windows and Linux, I can just use one code for all platform. Let me show you. Okay, here's a code. Now, instead of explaining the entire code, I'll just talk about the changes that I've made. All the changes that I made in this code are OS related, and I have added a comment called OS check. Now here's the first change. So if def nix hash include dlfcn.h, else include windows.h, and if. Now what this section of the code means is, if I define nix at compile time, then this code would load dlfcn.h, which is for Linux or Unix, else it will load windows.h. Similarly, here's a second change. If I define nix at compile time, then libhandle will be declared as of type void, else libhandle will be declared as h instance. And the next change is also quite similar. So if I define nix, then use dlopen to load the shared library, else use load library, which is actually meant for Windows, to load the DLL file. Here's the next one. If I define nix at compile time, then use dlsim, which is used by Linux and Unix, to load functions, else use getproc address to load functions. And we have something over here as well. Let me add OS check. Okay. So if I define nix at compile time, use dlclose to unload the shared library. dlclose is used on Linux and Unix. Else use free library, which is used on Windows, to unload the DLL file. Everything else in the code remains the same. Let's now talk about get slot info and get token info. Okay, I'll start with get slot list. So here's the code for get slot list. The purpose of this code is to just display the list of all available slots. Now most of this code is same as the previous one, so I'll just talk about things that I've added. And I'll start with the main function. So in the main function, the first thing that's going to happen is load HSM library. And then it's just going to display a message that says PKCS 11 library loaded. After that, it's going to call cinitialize to initialize the soft HSM cryptokey library. Immediately after that, it will call show all slots, and then it will call cfinalize. And after that, this program is going to exit. Let me show you what show all slots looks like. What's happening in this function. Here's the function. And in this function, I am calling cGetSlotList. cGetSlotList takes 3 arguments. The first argument is ckTrue, which means I want cGetSlotList to look for slots that has a token present in it. The next argument is null PTR or null pointer. I'll tell you in a moment why I'm passing null pointer here. Next argument is number of slots, which is of type ckulong or unsigned long. Number of slot is supposed to store the slot count, which means if getSlotList was able to detect 6 slots, then the value of number of slots is going to become 6. Similarly, if it detects 3 slots, then the value of number of slots is going to be 3. Let me explain why I'm passing null PTR as the second argument. I have a variable called slots, which is of type ckSlotID. Let me show you the declaration. So ckSlotID slots, the current value is null. This is a pointer. I am using slots as an array. An array is supposed to have a size, and I don't know what that size is going to be. When I execute this program, I don't know how many slots this program is going to detect. So let me scroll down. I just execute cGetSlotList with null pointer as the second argument, so I could find out how many slots were detected. So in this line, I am passing null PTR, so I could find out the number of slots that were detected. Once I have the number of slots detected, I can easily allocate the memory. And once the appropriate amount of memory has been allocated to slots, I will pass that slot variable into C getSlotList. And now in the second attempt, the list of all slots will be stored in slots variable. And using this for loop, I will display all slot on the screen. All right, let me execute the sample and show you how it works. To compile this program, I would run the command g++ getSlotList.cpp, and I want to output the executable into getSlotList file. I want to include header files from include directory. I'll hit enter. Compile success. Let's run this program. So getSlotList.exe, and here it is. So we have 3 slots. I'm going to open a new window and I'll run the command sofhsm2 util show slots. Okay, so these are the slots that are detected by this command. As you can see, this slot number starts with serial number 3224. That's what we see here. And we have 7175. That's what we see here. And the third slot, which is not initialized yet, it has slot number 2, and that's what we see here. Okay. Let's try to run allplatform.cpp. So g++ allplatform.cpp output into allplatform.cpp and include the header files. Compile success. Allplatform.exe. I'm going to pick this slot number. And I know the password, it's normal user. And this program also works. Let's go to the Linux operating system and see how to compile allplatform.cpp on Linux. Okay, I'm on Linux OS now, and I'll try to compile allplatform.cpp. So g++ allplatform.cpp. I want to output the executable into a file called allplatforms. I want to include the header files, which is in the includes directory, and I will hit enter. Now we're getting a message over here that says windows.h, no such file or directory. We are on Linux, so obviously windows.h should not exist. What we are missing here is dnix. So if you remember the code, let me go back to the code. Sorry, what is it called? Allplatform.cpp. Okay, so here we have mentioned a statement. If I defined nix, include dlfcn.h, else include windows.h. I never defined nix, that's why it was trying to include windows.h, which does not exist, and that's why we were getting that error. Let's go back and try again. So g++ allplatform.cpp, output this to all platforms, include the include directory for header files, and then define nix. Enter, and now the program compiles successfully. And if I try to execute it, obviously it will ask for the slot number and the slot password. For that, let's compile getSlotList. So g++ getSlotList.cpp, and I want to output this into getSlotList. include header files from the include directory and define next. Program compiles. Now I'll do get slot list. And these are the two slots that are detected on the system. Let's have a look. So soft HSM2 util, show slots. So we have this and we have slot number 1. That's what we see here. All right, I'm going to copy this and do all platform, paste the slot number and normal user, and now the program works fine. All right, and now I want to show you a behavior of C get slot list that you should be aware of. This is important. C get slot list reads information about detected slots from the memory. This information is written into the memory by C initialize. This means C get slot list will only show list of slots which were detected when C initialize was called, not after that. If a new slot is introduced after C initialize was called, then C get slot list will not be able to see it. Similarly, if a slot is removed after C initialize was called, then C get slot list will still show those deleted slots. Let me show you what I mean. To show this behavior, I have a program called getSlotList2. It's the same sample except what is happening in the main function. Let me show you what it is. So in the main function, I have a do loop which is supposed to execute or run 3 times. It's going to execute this function, show all slots. So it's going to display the list of all slots, and immediately after that, it's going to print a message that says press any key to continue. And it's going to pause the execution of the program. When this program is paused, I will open a new terminal and create a new slot. And then after I press enter, it should continue the execution and it will execute show all slots again. And it's going to do that like thrice. Let's compile and execute this program. I've split my screen into 2 parts. The window that you see on the left is where I would compile my sample codes, and the window on the right is where I would execute the soft HSM commands. So first I'm going to compile the sample code. So G++ get slot list 2. I want to output this into get slot list 2. Include everything from include directory and define next. I'll hit enter. Over here, I'll execute soft HSM util, show slots, and these are the 2 slots that I see. This is a slot that I initialized, and this is a free slot. Okay, let's execute get slot list 2. Okay, so at the moment I only see 2 slots. There's this one which matches with this, and another slot which is slot number 1, and it is waiting for me to press any key. While it's waiting, I'm going to create a new slot. So for this, the command is soft HSM util init token 3, and SO pin is going to be security officer, and the pin for the normal user is normal user. The label that I want to use is token 01. I'll hit enter. Okay, so token is generated, and if I do soft HSM util -- show slots, now I see a new slot. Let's press enter and see what happens. I still see 2 slots. Let's go ahead and generate another one. I'll name it token 02. Okay, slot has been generated. Let's do show slots again. And now we have 3 slots. So here's the first one, here's the second one, and here's the third one. And over here, I still see 2 slots. This is happening because C get slot list is reading information about detected slots from the memory, and that information is not updated. So what I'll do is I'll just hit enter. So the program has just quit. Now I'm going to execute this program again. And now, as you can see, instead of 2 slots, now it detects 4 slots, and I can see all of those slots. Let me show you what will happen if I try to delete these slots. So I already have 1, 2, 3 slots that were created by me. I'm going to opt sofhsm var lib sofhsm and tokens. So these are the slots. I'll just remove all of them. Sorry, recursive force. Okay, let's go back. And now if I run the command sofhsm util show slots, I only see 1 free slot. Let's press enter here and see what happens. I am still getting the list of all 4 slots. I hope you have understood what I mean. C get slot list reads information about detected slots from the memory which C initialize wrote when it was called. This information remains unchanged. In order to get an updated information, an application should call C finalize and then C initialize. This is also called reinitializing. This is exactly what I'm going to do in my next sample. Let me show you. Let's take a look at our next sample. So get slot list 3.cpp. Now this sample is almost identical to the one that I executed earlier. They are just like 2 changes. Let me show you what they are. I'll go to the main function. Here's the main function. So this is that same do while loop. Now inside that do while loop, I have introduced C initialize and C finalize. Let me show you what the previous sample was like. So 2.cpp. In the previous sample, okay, C initialize and C finalize are outside the loop. Okay, let's go back to get slot 3. And in this sample, I have C initialize and C finalize inside. So the flow of the program is going to be like this. It's going to load the library, display a message, PKCS 11 library loaded, and then immediately after that it's going to initialize, display the list of all slots, and then print a message that says press any key to continue. And the execution of this program will be paused. And while this program is paused, I'll just like delete a slot or maybe create a new slot. I'll get back here. And once I press any key, it will call C finalize. And it's just going to repeat itself. Again, it's in the next loop. Again, it's going to call C initialize, show all slots, and press any key. Let me show you this. I'll get out of this. And I'll compile this program. So C G++ get slot list 3.cpp, and I'm going to output this into get slot list 3. Include everything from include and define next. Okay, I'm back in the split view. Let me show you what we already have. So show slots. We don't have any slot. I mean, there's just 1 slot, but this slot is uninitialized. And when I run the command get slot list, that's exactly what I see here. So 1 slot detected, and that slot number is 0. Let's try to create a new slot. So sofhsm2 util init token free so pin security officer pin normal user label token 01. Okay, a new slot has been created with this serial number. I'll press enter here. Let's see what happens. All right, we are getting an updated information. Let's do this again. I'll create another slot called token 2. We have a new slot with this serial number. I'm going to press enter. And now we have the new slot. Let's try to delete this slot. Will it, hold on. Let's execute this program again. Okay, so right now there are 3 slots. One of them is not initialized. I'll go into opt soft-hsm var lib soft-hsm tokens, and I will delete one of them. Okay, go back. And now I see token 01 with this serial number, and the other one is gone. Let's press enter and see what happens. And now instead of 3 slots, I am seeing 2 slots. Let me try to generate a new slot again. So I will execute this program. I'll just name it test. Enter. Slot has been initialized with this serial number. Oh, sorry, this is the slot number. And I'll hit enter. And now I see 3 slots. So the point that I'm trying to make is, in order to get an updated information about a slot, an application has to call cFinalize so it could clear the information stored in the memory, and then call cInitialize to get an updated list of slots. Let me know if you have any questions about this in the comment section. I'll try to answer those questions. And that is it for this video. Please do check out the GitHub link in the description. All sample codes that I used in this video are uploaded over there. Thank you so much for watching. I hope there was something new for you to learn in this video. Please leave a like if you liked it. Subscribe to my channel if you're not already subscribed. I'll talk to you soon. Take care. Bye bye.